This is section 3.4, zeros of polynomial functions. Now, zeros is where your graph crosses the x-axis. So that's going to be an important thing to note for working problems. Finding zeros of polynomials. Step 1, put polynomial on y1, 0 on y2. Then we'll do second trace, choose intersect, enter on first curve, enter on second curve, and then we'll input an x value close to the answer and press enter. If you have decimals, second mode to exit out, and then math, enter. If you have more answers, go back to step. Now, we should already have our polynomial on y1, 0, y2, so you shouldn't have to do that again. So we're going to go back to step 2. Then step 5, plug all your answers from the calculator into synthetic division and find the rest of the answers. Okay, let's take a look at our first problem. Now we want to find all the zeros. Our steps said to put the polynomial on y1, 0 on y2. Go to y equals my x caret 3 minus 3x squared minus 18x plus 40. Then we'll go put a 0 on y2. Now your largest power tells you how many answers you're going to have. So since we have the third power, that means we're going to have 3 answers. So again, largest power tells you how many answers. So I'll do second trace. This takes us into the calc menu. And I say to choose the intersect. Now, different ways you can choose it. You can down arrow to it and press enter, or you can simply press the 5 once you're in that menu. Now, remember what I said? I said your zeros are wherever it crosses the x-axis. So when I look at it, it looks like -4, 2, 3, 4, and 5 are our answers. We're going to go through this. Notice in the bottom left-hand corner, it's saying first curve question mark. That's this part here. You just enter on first curve. So nothing special you have to do. You just simply press enter. Then it comes up and asks us for a second curve question mark. And again, nothing fancy you have to do. Just do enter on second curve. So you just press enter. Now here we want to input an x value close to the answer and press enter. We think the answer is at -4, so let's put in -5. The negative is one in the very bottom row. And then press enter. And it comes back and gives us our first answer, which is -4. Now we got 2 other answers. So I'm going to go through the process again. I'll do second trace, choose 5 for intersect. Enter our first curve, enter our second curve. And I think the next one is 2. You don't have to actually input a guess close to it. You can input what you think the answer is. So if I put 2 in and press enter, it'll come back and tell me my intersection is x equals 2, which tells me that's my second answer. And then we got one more. So we'll do a second trace, choose intersect, enter our first curve, enter our second curve. Now for the guess, there's a third way to do the guess. You can use your arrow keys to move your flashing cursor over close to the one you're trying to find. It doesn't have to be right on top of it. It just has to be closer to that one than it is to the other ones. And once you get over there relatively close, you just press enter. And it'll find whichever one it's closest to. It tells us our third answer is x equals 5. That technique is handy if you're going into business calc. There's a lot of times, and trig. There's a lot of times in business calc and trig, you don't know what those tick marks actually represent. So using your arrow keys is a better way to go over to select it. Now, our fundamental theorem of algebra tells us our largest power tells us some answers. And again, we said 3, and we found 3. Since we found all via the calculator, we don't have to plug in a synthetic division. So if the calculator gives you all of your answers, you don't have that problem. Let's take a look at this one. Again, our largest power is 3, so that power of 3 tells us we're going to have 3 answers. Okay, so we'll go to y equals on y1 from a polynomial. 4x to the third minus 17x squared plus 16x minus 3 do second trace, Choose number 5 for intersect. You can see here in the middle, it comes up a little bit above the x-axis and goes back down. That means there's two answers real close to each other. But there's 3 places where it crosses the x-axis. So first thing I'm going to do is enter on first curve, enter on second curve, and I'm going to put 0 in for the guess. Now this comes back and tells us our answer is 0.25. And we don't want decimals at all on these, which is fine. Because we know if we have decimals, we don't want to do this. So we'll do a second mode, math, enter. Second mode, math, enter. Now I know that was a pretty easy one to change to a fraction, 0.25, but they won't always be that easy, and so that's how you change something to a fraction. Well, we still need more answers. So I do second trace, choose intersect, enter our first curve, enter our second curve, and I'll put 1 in for the guess. And it comes back and tells us intersection is x equals 1. So x equals 1 is our second answer. Then we got another one, looks like 3 or 4. Second trace, choose intersect, enter 4 is 3. So x equals 3. Now we said we're going to have 3 answers. We found all 3 via the calculator, so we don't need to do any synthetic division or anything. Questions on that so far? Okay, let's take a look at this one. Number 3. X to the third minus 4x squared plus 9x minus 10. It says find all the zeros. What that means when it says find the zeros, it says set it equal to 0 and solve it. We know our largest power tells us how many answers we're going to have on multi-theorem of algebra. So we're going to have 3 answers. But I can't factor this. So we go to the calculator to see what kind of answers we can find. If it gives us all 3, fantastic. We're done. I'll put my polynomial what I want. So I got x to the third minus 4x squared plus 9x minus 10. Do my second trace. Choose intersect. It looks like our only answer is 2, but we'll go through and verify that. Enter our first curve, enter our second curve, let me put 2 in for the guess. Comes back and tells us x equals 2. But nice if it gave us all answers, but no. Okay, so there's no more answers to be found via the calculator, so go to step 5. Plug all your answers from the calculator into synthetic division and find the rest of the answers. So we're going to take that 2 we just found, and we'll plug that in synthetic division. Remember, we have x to the third there. This would be x squared, x, no x. Start with your x to the largest power. You have 1 for each one you want down. Add, multiply, add, multiply, add, multiply, add. Notice we get a zeros remainder. That tells us that the number in the box is an answer, 0. So x equals 2 is our first answer. We saw that in the last section with the factor theorem. Now at this point, this is x to the third. This will be 1 degree lower. So this will be x squared. This will be x. And this will be no x. So I got x squared minus 2x plus 5. And I set it equal to 0. Why set it equal to 0? Well, we're finding 0. So you constantly set things equal to 0. Now, this cannot factor. So I'm going to use quadratic formula. A is whatever's in front of your x squared, which is 1. B is what's in front of your x, which is negative 2. C is your number at the end, which is 5. So I got negative b plus or minus square root of b squared minus 4ac all over 2a. So negative 2 plus or minus square root of negative 2 squared minus 4 times a, which is 1, times c, which is 5. All over 2a. Negative gives us positive. Negative 2 squared is 4. Minus 4 times 1 times 5 is 20 over 2. 4 minus 20 is negative 16 over 2. Now remember, a negative inside of your square root gives you an I, and square root of 16 is 4. So that's going to become 2 plus or minus 4i over 2. If you have an I up here, imaginary part, you must put the imaginary part for the real part. So put 2 over 2 plus or minus 4 over 2 with an I. It gives us 1 plus or minus 2i. Fundamental theorem of algebra says that your large power tells you how many answers you can have. It doesn't say they're all going to be real. We had one real one we found via the calculator, and then we had two answers that had imaginary numbers to them. That plus or minus accounts for 2 answers, so we actually got 3 answers circled. Questions on that one? Take a look at another quadratic formula. Take a look at this one. X to the fourth, 5x to the third, minus 5x squared, minus 15x, plus 14 equals 0. Again, our largest power is the fourth power, which means we're going to have 4 answers when it's all said and done. We use a calculator to find as many as we can, then we use synthetic division to find the remainder of them.
So if for some reason they were trying to do this without a calculator, would you use synthetic division to find all of them?
You're not going to use a calculator? You're not going to use a calculator? Or?
No, like if for some reason.
Oh. I can show.
Possible?
Yeah.
Okay.
They're just very tedious.
Okay.
That one probably doesn't show it real well. I'll see if I can find another one that shows better. Okay, so I'll go put in my calculator. X to the fourth. This one might show it well. I take that back. Okay, so I'm going to do second trace, choose intersect. Now there's definitely two answers on the left side there, and on the right side you can see it comes down a little bit below the x-axis and goes back up, which means there's two answers right close to each other there. It doesn't matter that we can't see it really. Calculator doesn't need for us to see it in order to find it. So let's find this one on the far left. I'll do enter on, did I go the right one? I don't think I did. Let's try it again. Second trace, choose intersect. There you go. It should say first curve, not lower bound or whatever it was. Okay, enter on first curve, enter on second curve. For the guess, I'll put in -5. That looks like the one closest to that one on the far left. Gives me -5.316625. That's okay. I gave you a step on how to change that to a fraction. So we'll do second mode. And I'll press math, enter. Now that does not change to a fraction, which means I can't use it. We'll circle back around to that one. So let's see what else we can find. Second trace, choose intersect. Enter first curve, enter second curve. Looks like -2. And it is. Let's put 0 in for the guess, see if we can find this one on the left side where it comes down just a little bit. Might be 1. Second trace, choose intersect. Enter 0. X equals 1. Well, let's put in 3. Don't want to go too far out, but it doesn't have to be right close either. Okay, second trace, choose 5 for intersect. Enter 3. Yeah, let's circle back around. So it's too far out. Let's do 2. Second trace. Oops. Second. Keep. Intersect. Enter, and then 2. And we get 1.3166248. Again, we can't have decimals, but I know how to change it to fraction. I do second mode, math, enter. Doesn't change, which means we can't use it. And they actually come in pairs. If you have one that will not change to a fraction, you'll have another one that won't change to a fraction. Well, we found 2 answers, so that's as good as it gets. So let's plug those in synthetic division. Does not matter which one you start with. I'll start with 1. So 1, 5, -5, -15, 14. That's my x to the fourth, my x to the third, my x squared, x, no x. It self-checks because you know you should get 0's remainder. So add, multiply, add, multiply, add, multiply, add, multiply, add. Then we get a 0's remainder. Again, no big surprise. Calc told us it was an answer, but that confirms x equals 1 is our first answer. Now we started with x to the fourth. We're now down to x to the third. Because when you find an answer, it takes it down one more power. Now we're going to plug in our second answer in that line we just found. You don't go back to the original, you plug in the line you just found. Add, multiply, add, multiply, add, multiply, add. And we get another 0 for the remainder, which is not a surprise because calculus says it was an answer. This is now down to x squared. So each power you or each answer you plug in takes it down one more power. This would be our x, and this would be our no x. So we got x squared plus 4x minus 7 equal to 0. This is not factor, so we're going to use quadratic formula. A is what's in front of our x squared, which is 1. B is what's in front of our x, which is 4. And C is our constant term, the number at the end. And we're going to have negative b plus or minus square root of b squared minus 4ac all over 2a. We have negative 4 plus or minus 4 squared minus 4 times 1 times negative 7. Gives us negative 4 plus or minus 4 squared is 16. Negative 4 times 1 is negative 4 times negative 7 is a positive 28. I forgot to put 2 times a. 2 times 1, which is 2. That gives us negative 4 plus or minus square root of 44 over 2. Simplify that. 44 is 2 times 2 times 11. Remember, a pair of numbers comes out as a single. So the pair of 2's comes out as a single 2. So we got negative 4 plus or minus 2 squared 11 over 2. Now we talked about this when we covered the quadratic formula. If you can divide these three numbers by saying number, do so. And those are all divisible by 2. So that's going to give us negative 2 plus or minus squared 11. The reason why they would not change to fraction form is they weren't really fractional answers. They were radical answers. And TA3, TA4 will not give you radical answers. Okay, so if I was doing this completely by hand, the number has to be in standard form. The number at the end would be our P. The number at the beginning would be our Q. And we'd write down all the products to give us 14. And this one's pretty easy. 1 times 14 would give us 14. And 2 times 7 would give us 14. In addition, it's a positive 14, isn't it? So a negative 1 times a negative 14 would give us a positive 14. So to handle, no matter what the sign is, to handle it, you put a plus or minus in front of each one. Now Q is whatever number's in front of our x to the fourth, which is the coefficient, which is 1. And you don't have to duplicate it because the only thing that give us 1 is 1 times 1. So you don't have to put 1 twice. But again, it's a positive 1. You could have negative 1 times negative 1 or positive 1 times a positive 1. So to handle all the cases, you do that. Now all of our possible answers are P over Q. And so we take each value of P here and put it over this Q. So we've got plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 7 over 1, plus or minus 14 over 1, which gives us plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14. Now what we do is you plug in each one of these values and see which ones work. Read my own writing. Negative 15. Somebody just hadn't hung up. Negative 15. Okay, so add, multiply, add, multiply, add, multiply, add, multiply, add. We're looking for zeros remainder. So negative 1 doesn't work, then we go to positive 1. So add, multiply, add, multiply, add, multiply, add, multiply. Got a 0. So then that means that our first answer is x equals 1. Now keep in mind, we can now work with this line right here. This started out as x to the fourth. This is now down to x to the third. Now we could try 1 again. There's nothing saying 1 wouldn't work a second time. 1, 6, 1, negative 14. So add, multiply, add, multiply, add, multiply, add. No. So I go to my next number, which is negative 2. Add, multiply, add, multiply, add, multiply, add. Again, we're looking for a remainder of 0. So I go to my next possible answer, 2. So add, multiply, add, multiply, add, multiply, add, 46. No. So I'm going to go to my next possible answer, which is, oh, what are the answers?
On the first one,
Yeah.
negative 2 plus or minus 11.
I mean, off the calculator. What did we get off the calculator?
Negative 2 and 1.
Did I screw up negative 2 then? I must have. Oh, what am I doing? This is my new line. This is the one I should have been plugging it into. Okay, -2. 1, add, okay, 4, -8, -7, 14, 0. And then we're down to the x squared level. So this would give us our x squared plus 4x minus 7 equals 0. And then I solve it using our what we did before. Very tedious process. And this is an easy one. You see, I screwed it up. I didn't screw it up on purpose, but that's I'd run across a problem where I'd have to do 20 synthetic divisions, and I'd get all 19 of them right. The one I'd screw up, you would guess, is the one that was the answer. So then I had to go back and redo them. You got very good at synthetic division. Where it became big is where you had a number in front here and a larger number here. For example, this one wouldn't be very pretty. 1 times 40, there's 2 numbers there. 2 times 20, so another 2. 4 times 10. 5 times 8. So you got eight numbers there with the plus or minuses, which means you got 16 possibilities because you got the plus or minus of each one. I don't know what 54 would be, but I'm assuming that wouldn't be real pleasant. I don't see it with numbers in front of the x of power. Anyway, that's how you do it by hand. Yeah, the graphing calculators made college algebra twice as easy as it was. Yeah, not hard. It's just time consuming. Look at that one. Okay, number 5. We're going to see matrices in this class toward the end, and we're going to use calculator for the most part. I took a class on matrix algebra, two credit class, and it basically covered most of what you'll see completely by hand. That's funny because it was so boring. I've never been in a math class. It was so boring to see it by hand. It wasn't hard stuff. It's just very tedious, like you just saw: add, multiply, subtract, go to sleep, add, multiply. And it's funny because the instructor really spoke in a very monotone voice, and so it made it even worse. But I wondered if the matrix algebra by hand over the years had made him a very monotone, boring person. At one point in time, he phased out in the middle of the class, and all instructors do that. Kind of, your mind's thinking something else. He phased out for about 5 minutes. We're sitting there looking at each other and looking at the clocks, like, can we go? But he's looking off in the distance, and he finally came back, and I don't think he even realized he was gone. Maybe he was having some kind of medical episode, and we didn't even realize it. But either that or he's sitting there. I had such high hopes for my future, and here I am teaching matrix algebra. Okay, let's take a look at this one. Okay, so we're going to have 4 answers when it's all said and done. So I have x to the 4th minus x to the 3rd plus 3x squared minus 9x minus 54. I'll do second trace, choose intersect. Looks like -2 and 3. And we could just plug in synthetic division because, you know, if it gives you a zeros remainder, that means it is one of your answers. But I'll go through and verify it. Inner, -2. It is -2. Second trace, intersect, inner, 3. Comes back, it tells me 3. So it is just like we think, -2 and 3. Been nice if we got all of our answers, but we got something to work with. So I'll start plugging these in. This is our x to the 4th. Okay, add, multiply, add, multiply, add, multiply, add, multiply, add. Get a 0. Tells us we found our first 0, or our first answer. So x equals -2. Again, no big surprise. Calculator told us this is going to be an answer. We're now down to x to the 3rd, because each answer you plug in and you get a zeros remainder, it takes it down to 1 more power. And I'll plug in the next number, which is 3. So add, multiply, add, multiply, add, multiply, add. We get another zeros remainder, which means we found our second answer, x equals 3. And we're now down to x squared. And that's x, and this is no x. I like these kind of problems for the test because they're easier than the quadratic formula. Now, what makes this easier is the middle term's missing. It has a 0 for it. And when that's missing, then you don't write it down. So you got x squared plus 9 equals 0. But even more than that, you can use the square root property. Square root property takes 9 over the other side, becomes a -9. And square root property says drop your squared, put a plus or minus square root on the other side. Remember, a negative inside of square root gives an I, and then square root of 9 is 3. So we got x is equal to plus or minus 3i. We have 4 answers. 2 of them have imaginary parts to them. We got a -3i and we got a positive 3i. These come in pairs. Your i's come in pairs. So if you have a -3i, you'll have a positive 3i. If you have a -4i, you'll have a positive 4i. So they're conjugates is what that's the name of that is. But keep that in mind. Okay, let's take a look at this one. Third plus 30x minus 25. This is one I would sometimes screw up on. We'll talk about y here in a minute. Let's go to the calculator. So x to the 4th minus 6x to the 3rd plus 30x minus 25. Still have 0 on y2, so we'll do second trace, choose intersect. Looks like -2, 1, 2, and 5. So we'll do enter our first curve, enter our second curve, I'll put in -2. I get -2.236068. Doesn't look promising, but let me try to change it to a fraction. So I'll do second mode, math, enter. Doesn't change, so I can't use it. It's probably a radical answer. Go do second trace, choose intersect. Our next one we think is 1, so I do inner, and I'll put 1 in for the guess. And comes back, tells me intersection is x equals 1. Next one is right beside it, like 2. So second trace, choose intersect. Enter, put 2 in. 2.236068. That looks like a positive version of the other one. So it's not going to change either. I could try it, but let's try 5. Second trace, choose intersect. Inner, 5. And tells me x equals 5. Okay. Now we're going to plug these into synthetic division. This is where I sometimes screw up. Is what's missing. The x squared. Yeah, you had to put a 0 there. And you've noticed I've gotten lazy on that. You know, I was so good about it in the previous class where I put an x to the 4th here, and then I had 1 for each power going down. And that is a good thing, because then you don't ever mess up like that. But I get lazy. Okay, so add, multiply, add, multiply, add, multiply, add, multiply, add. That tells us that our first answer is x equals 1. This was x to the 4th. We're now down to x to the 3rd. Now I want to plug in my second answer. Add, multiply, add, multiply, add, multiply, add. We get another remainder of 0, which means x equals 5 is our second answer. And now we're down to x squared, and this is x, and this is our constant term, or no x. Again, when you have your middle terms missing, it makes it simpler. So I got x squared minus 5 equals 0. Take negative 5 over to the right side, becomes positive 5. Drop the squared, put a plus or minus square root on the other side. Reason why they would not change to fraction is, again, they are radical answers. One was a negative square root of 5, and one was a positive square root of 5. Questions on the square root property? Okay, let's take a look at what's different about this one. X to the 4th plus 4x to the 3rd, 6x squared plus 4x plus 1 equals 0. X to the 4th plus 4x to the 3rd, 6x squared plus 4x plus 1. Second trace, choose intersect. Now I don't see it coming down below the x-axis. It's actually touching at a point. It's touching at -1. But I'm going to go through and try to put -2 in for my guess. We're going to see what happens. So I do enter on first curve, enter on second curve, and I put in -2. Comes back and gives us -0.9991358. If I try to change it to a fraction, it won't change to a fraction. If I try to put 0 in, second trace, choose intersect, enter 0, I get -1.000852. And that would not change to a fraction. When it touches at a point, it does weird things. That's what the book was kind of emphasizing, the touching at a point earlier. Remember, touching at a point meant that your multiplicity would be like 2 or 4. Basically, your answer repeats. If I put in -1 for my guess, it'll come back and tell you -1. It's kind of it sounds stupid, but in order to get the answer, you have to input the answer as your guess. And that's when it touches at a point. Okay, well, it'd be nice if we found more, but we can work with that. Keeping in mind that it repeats because it touches at a point. Okay, so plug that in. This is x to the 4th currently. So add, multiply, add, multiply, add, multiply, add, multiply, add. That tells us x equals -1 is our first answer. And now we're down to x to the 3rd. Since our answer repeats, we're going to try -1 again. So add, multiply, add, multiply, add, multiply, add. We get another 0. So that means our second answer is x equals -1. We're now down to x squared. Now there's nothing saying that the answer is not going to be -1 the third time. So let's try it. So add, multiply, add, multiply, add. We get another 0, which means our third answer is -1. And now we're down to x and no x. So x plus 1 equals 0, and solve for x, and we get x equals -1. Fundamental theorem of algebra says that the largest power tells you how many answers you can have. It doesn't say they're all not going to be the same, which it was in this case. Anyway, that's an example of repeating. And I think that will always happen whenever it touches at a point. So if you look at the graph, it's touching at a point, that's the answer repeats. But sometimes it's so zoomed in, you can't really see it touching at a point. So it's a little trickier. Okay. 3 and 2i are zeros. I don't really like this problem, but sometimes it appears on final exams. So that's why I started including it and covering it. To me, it's kind of a stupid question. We're going backwards. They're giving you the answers, and they want you to come back with the original polynomial. Now, that concept by itself isn't stupid. Just I'll talk about why it's stupid for this problem. Okay, now they said 3 is a 0. That means one of our answers is x equals 3. They said 2i is a 0. That means one of our answers is 2i. And remember, I said that i's come in pairs. So if we have a positive 2i, we'll have a negative 2i. Now this n equals 3, that indicates our degree. It means our largest power will be x to the 3rd when we're done. It also means you have 3 answers, which is why you have to account for that missing one. Now going backwards, if you think about doing it the other direction, x squared minus 5x plus 6 equals 0, you'd factor this. You set each factor equal to 0. Get x equals 2, x equals 3, and we'd have 2 and 3. So it's like we're going in reverse. Start out with these. We just put the x equals next to each other. Going back here, I would take this 2 on the same side as the x, this 3 on the same side as the x. So I'll do here. Take this 3 over, take this 2i over, and take this negative 2i over. So we've got x minus 3 equals 0, x minus 2i equals 0, and x plus 2i equals 0. Going back one more step, we would put parentheses around each one, put them next to each other. So put parentheses around each one, put them next to each other. And although you can't really see it with my example over here on the side, going backwards here, we would FOIL, multiply everything together. That's what I'm going to do here. I'm going to start out with multiplying these two together. These are called conjugates. Conjugates, the first part's the same, x and x. The last part's the same, 2i and 2i. But the sign in the middle is different. When you got conjugates, all you have to do is multiply your first parts together and your last parts. X times x is x squared. Negative 2i times 2i gives us negative 4i squared. This is the one and only place in this class you really use this information. Nowhere else do you need to know what I squared is equal to. Remember that from Algebra 2? What's it equal to? Negative 1. If you go on and take trig, you'll see that again. But yeah, we only use that in this one place here. Which means I'm going to go through and replace my I squared with negative 1. In a sense, what it does is it flips the sign in front of the 4 there. So that becomes x squared plus 4. Now multiply those together. Then we get x to the third minus 3x squared plus 4x minus 12. Reason I don't like these problems. No, this doesn't have anything to do with the one that just worked. If I set my zeros here, my zeros here, and my zeros here. And your goal is to go backwards and get the original polynomial. Well, I could draw the polynomial this way. I could draw it that way. How many different ways could I draw that polynomial? Endless. There's an infinite number of polynomials that match those three answers. So coming up with this is actually pretty meaningless. That's just one of the infinite answers. So it's just like, well, this is stupid. You know, it's just like, but it, like I say, it's appeared on Theorems in the past, so I've covered it. Now, if you, there is a way to make them so that they are more meaningful, and that's where you put an initial condition on there. Questions on that problem? Well, we're done with that section. Now I think we're gonna stop there because I got a meeting I gotta head to, and I need to have a little bit of time to prepare for it. Questions? Anything?
you, I have the SAT on Wednesday.
Uh-huh.
And I don't know what time it's gonna get out. And I'll try and make it to class if it gets out possible, but I'm making it.
Okay, that's no problem. I record lectures, so that's no problem.